So Darwin gave us On the Origin of Species, and in the Galapagos Islands, mainly recovering, well, in addition to many fossils throughout his journey on the Beagle, making observations on all the different species on the Galapagos Islands. Here we can see a marine iguana, a unique species inhabiting the Galapagos. We saw a video on that iguana, what was in South America, mainly living off of dry land and vegetation in the Galapagos. We see adaptations for that, now new species that adapted to that environment in a marine surrounding to where that iguana is now able to swim successfully and gather the vegetation in the form of seaweed underwater in order to survive. So that's really neat. So adaptations definitely can lead to different species. Diversity of life evolved through speciation, the process by which one species now splits into two or more species, as seen with this iguana example. So what is a species? You guys have definitely heard that term before. How do we define that? A species is a group of populations whose members have the potential to interbreed with one another and produce fertile offspring. That's very important. And so what do I mean by fertile offspring? I'm saying that their offspring, if two members of the same species do procreate, their offspring will then be able to also reproduce and make offspring themselves. They're fertile. Because you're going to learn in some examples that I give you that you can have different species mating and their offspring are not fertile. They're actually sterile. So then you wouldn't classify them as the same species. Yeah. So this is important. Back in the day, we were more concerned with physical appearance of organisms. Do they look the same? And we were comfortable labeling them the same species. And for the most part, we're able to categorize the different organisms out there using that concept. But it's a huge, what's the word I'm looking for? Mistake, because like these iguanas here, for instance, this dryland iguana and versus this marine environment iguana, they are different species. Yet back in the day, we would have considered them the same species. They look quite similar, yet they're quite different. And so today we use this idea of reproductive compatibility. Are they able to procreate with each other? Are they able to make fertile offspring rather than do they look the same? Because many different species out there, as you guys are going to learn, look the same, but they do not reproduce together. Or if they do not have fertile offspring. Their offspring is sterile. Other definitions include those, if you're getting more precise, and I like this one a little bit better, molecular data really gave us a beautiful way to be able to classify all these different organisms based on their genetics and how similar they are at the DNA molecular level. And we could actually group them more successfully in those phylogenetic trees, which I'll show you, which I've gone over in evolution, looking at their DNA, seeing how similar they are, and then finding their common ancestors with one another. It is important that this definition I gave you, a species, a group of populations whose members have the potential to interbreed and produce fertile offspring, it cannot be applied in all situations. That'd be great if it could. It can't. You cannot use this definition for asexual organisms. I will go over asexual reproduction in future lectures. Asexual organisms don't procreate with another organism. They will make offsprings, clones of themselves. That can't be applied in this definition. And fossils. Fossils are long gone. You can't apply the definition of a species in a fossil. So you would rather use molecular data for something like that.